Okay, Assalamualaikum. Good morning, everyone. How do you do? Okay, I hope you're all ready and everyone is doing fine. So today we will continue with our physics lesson, specific heat capacity, problem solving. Okay, before I begin, okay, I hope all of you get ready with this lesson. Make yourself comfortable and get ready with all the question. Have you tried on them? Ada cuba tak soalan ini? Ada cuba jawab tak? Okay, for those who would like to join me in the studio, you can click on this Conti link. Boleh klik link ini. So I share to you my screen now. If you're all good to go. Okay, for those who are not in yet, okay, monitor, please call up your friends. Okay, we are about to start with the lesson now. Okay, we don't want to waste more time because we have a lot of questions to discuss today. Belum cuba, kenapa belum cuba Ong Cheng? Okay. Okay, students, yesterday we have solved a few problems according to specific heat capacity. Okay, and then today we continue with more questions. All these questions are SPM past year questions. Okay, semuanya soalan SPM tahun-tahun yang lepas. Okay, welcome Kafai, welcome Nicholas, welcome to my studio. And the rest of you, I hope you can participate actively at the live chat down there. Okay, please show to us that you are present and you are involved in this discussion. Okay, if possible, I don't want the same person to answer all the time. Yang lain pun you kena cuba jawab. Okay, and if you get it wrong, then we are going to correct them for you. Okay, so if you are good to go, let's continue with the question. What do we have here? Okay, we have a lead bullet. Okay, there is a bullet moving at the velocity of 200 meter per second. So you can highlight the given information. It hits a sandbag. Okay, the temperature of the lead bullet rises by 50 degrees Celsius. Assuming that all kinetic energy of the bullet converted into heat energy, calculate the specific heat capacity of the bullet. So students, you are asked to find the value for C, specific heat capacity of the bullet. Okay. So what is the formula to be applied in this question? You nak apply formula apa? Okay, can you hear me clearly? Can you please respond if you can hear me clearly?
Yes.
Okay, very good. Thank you, Nicholas. Thank you, Kafai. Okay, so how to understand this question?
Hello.
Hello.
Okay.
Okay, sorry for the technical error. Okay, cikgu punya bateri tadi padam. Okay?
Okay.
Okay, so I show to you my screen again. Okay, students. So how to solve these problems? Okay, first and foremost, you must understand what is the conversion of energy occur here. Apa perubahan tenaga yang berlaku? So, kinetic energy of the bullet convert into heat energy. Okay, again, kinetic energy of the bullet convert into heat energy. So this is what the conversion of energy we can write. The heat energy generated equal to the kinetic energy loss. Okay. Then we may write the formula mc delta theta. This is heat. Okay, Q equal to mc delta theta equal to the kinetic energy loss. Kinetic energy is half mv squared. Okay, half mv squared. Okay, then you can do the substitution. Okay, can you solve for this equation? Tell me what is the specific heat capacity of the bullet. Okay, everyone. Okay, if you have found the answer, you may share the answer to others and we can compare. Okay, either you get it wrong or right. Okay, I give you a few seconds, a few minutes to try and find the value of the specific heat capacity of the bullet. Okay, Nicholas get 400. Okay, how about the rest of you? What do you get? What is the specific heat capacity of the bullet? Okay, so if you do the substitution, okay, this is M. M is not given in this equation, in this question, but it's no problem since we can cancel off, okay, M at both sides since it is both refer to the bullet, okay. So we are looking for this C. This is the temperature change of the bullet. Again, this is its mass and this is its velocity given. So you cancel off M from both sides. Okay, we cancel off M. And then you solve for others. So you will find that specific heat capacity of the bullet will be 400 joule per kilogram per degree Celsius. Okay, 400 joule per kilogram per degree Celsius. Okay, I hope you are clear how to find this value. Okay. Okay, then can we move to the next question? Okay, we move to the next question now. It will be, again, we have a lead. Now it's a ball. Okay, it's a lead ball with a mass of 300 to 320 gram. Okay, it's dropped from a height of 12 meter. So it is dropped from a height of 12 meter. So you know when the object is dropped from a height of 12 meter, what is the conversion of energy that took place? Okay, what is it? Conversion of energy that took place? It is potential energy convert into heat energy. So the potential energy lost by the ball equal to the heat energy it gained. Okay, so by this we can write mgh, this is potential energy, equal to mc delta theta. Okay, the heat energy. And again, you can do the substitution. Okay, this is the mass of the bullet in gram. So you must convert them into kg, 0.32. This is gravitational acceleration, 9.81. And this is the displacement, the height falling, 12 meter. And again, this is the mass which you can cancel off. And then this is 128. Okay, they give you the specific heat capacity. Now for you to find the temperature change. Okay, find the temperature change. So what is the temperature change, students? So if you calculate, the temperature change is 0.92 degrees Celsius. Can you check, is this correct? Can you check for me, is this answer correct? 0.92 degrees Celsius. Okay. Do you agree with my answer?
Yes.
Okay, very good. Okay. So this is how we solve for this problem where potential energy convert into heat energy. Okay, then what is the next question? Okay, the next question is welcome, Yu Qian. Okay, now this is objective question. Question 1, question 2, question 3, question 4. Okay, I want you to read through and share the answer at the live chat. What is the answer for number 1, number 2, number 3, and number 4? Okay. Number 1, given the specific heat capacity of aluminium 900 joule per kilogram per degree Celsius, which statement explain the specific heat capacity of aluminium correctly? Is it A, B, C, or D? Second question, why water is used as a cooling agent in a cooling system of a car engine? And number 3, heat energy supply at the same rate to 0.4 kg substance P and 0.4 kg substance Q in similar containers. Temperature of substance P rise faster. So which one is correct? This is because substance P what? Okay, and number 4, you can see in the diagram, we have solid block M and N with equal mass are being heated, okay, with the same amount of heat energy. Initial temperature of M and N is the same, and it is observed that M is getting hot faster compared to N. So this observation is due to the difference in what? Okay, is it density, is it melting point, is it latent heat of fusion, or specific heat capacity? Okay, which one is your answer, students? Number 1, number 2, number 3, number 4. Okay. Mana answer? B, D, D, D. Nicholas say B, D, D, D. Can you share your answer in the comment section so others can see your answer? Kalau you jawab at the private chat, only we in the studio can read it. Okay? Okay, the rest of you down there, what do you say? Number 1, number 2, number 3, number 4. So number 1, it should be, okay, Nicholas say B, D, D, D. Number 1, it should be B. Okay, the temperature of 1 kilogram of aluminium rise by 1 degree Celsius when it absorbs 900 joule of heat energy. Okay, number 2, what is the answer? Okay, for number 2, because water can absorb a lot of heat. Yes, okay, water can absorb a lot of heat. Okay, then number 4, what is the answer for number 4? Number 3. Okay, number 3, because substance P has smaller specific heat capacity than substance Q. Okay, very good. And then number 4, it is due to difference in specific heat capacity. So the answer is boy, donkey, 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 B, D, D, D. Okay, very good, Nicholas. Okay, those who get it right, very well. Congratulations. Okay, then we check on the next question. Question 16 and 17. Okay, 16 and 17 student, what do you say? Which step cannot increase the accuracy of C? C is specific heat capacity. Okay, diagram show apparatus setup to determine specific heat capacity C of an aluminium block. So which is the step cannot increase the accuracy? Okay, and then diagram number 17, it shows we have 3 blocks. The first one is lead block. Second, we have iron block. And then third, we have aluminium block. If I can zoom out for you, this is the specific heat capacity for each of these block. Lead with 130, iron with 460, and aluminium with 910, okay, joule per kilogram per degree Celsius. So the question is, which statement is correct at the end of 15 minutes? Okay, so all these block with the same mass are heated with the same amount of heat energy for about 15 minutes. Okay, so number 16, what is your answer? Number 16, which one cannot increase the accuracy of C? So answer is boy. Okay, cover the top of the aluminium block with aluminium foil. Okay, you cover the top but you didn't cover the side, it's nothing, it doesn't help. Plus you cover with aluminium foil. Aluminium foil is a heat conductor, so it won't prevent the heat from lost to the surrounding, so it doesn't help. So either you can wrap the aluminium block with cotton, or you can pour some lubricating oil into the hole so to make sure thermal contact is more efficient. Or you can put the aluminium block on a polystyrene sheet. Okay, polystyrene sheet is a heat insulator. So you can place this aluminium block on top of a polystyrene sheet to prevent heat loss, okay,
Teacher,
to the table. Yes.
the aluminum foil can reflect the heat energy.
Huh?
The aluminum foil can
Yeah.
reflect the heat energy. Reflect.
If you read through, cover the top, mean you cover the top only. And what about the rest? Okay, so still it doesn't prevent, it doesn't give, it doesn't help to increase the accuracy of C. You have to cover the whole block. Tak perlu cover the top only. And then aluminium foil ini, plus this is not an insulator. Okay, when you cover the aluminium block, make sure you cover it with insulator, heat insulator. Okay, not heat conductor. Okay, I hope you are clear with the questions. Okay, now for question 17. Okay, D ini which one? Refer to which question? Eliana. Okay, so for number 17, which statement is correct at the end of 15 minutes? Answer is D. Okay, the final temperature of the lead block is higher. Why? Because it has a lower specific heat capacity, so the temperature change is the highest. Okay. Okay, then we go to the subject, to the structure question. This is structure question SPM 2010, question number 2. Okay, you are given two types of pots and their characteristic as well. On the left side, what do we have? We have a clay pot. Okay, and on the right side, it is a copper pot. Okay, this is the handle made from clay. Ini the handle made from polymer, and the specific heat capacity and mass are given for each pot. Okay, 900 for clay pot, 390 for copper pot. Mass for clay pot is 3.5 kg and 2.5 for copper pot. Okay, the first question, what is the meaning of specific heat capacity, students? What is the meaning of specific heat capacity? Okay, remember when you are asked to write a meaning or definition, you must write in a proper way. Okay, tuliskan dengan lengkap. Okay, so what is the meaning of specific heat capacity? You may refer to the previous notes I give you earlier. So it is the quantity of heat. Okay, the quantity of heat or the amount of heat required, okay, to raise the temperature of 1 kilogram substance by 1 degree Celsius. Okay, please bear with your spelling, Nicholas. Okay, the quantity of heat required to raise temperature of 1 kilogram substance by 1 degree Celsius. So the keyword is amount of energy. Okay, and then rise 1 degree Celsius, 1 kilogram substance. So there are 4 keywords you must type there. Okay, and then question B, based on table 8, we have to state the suitable characteristic of the pot if it is to be used for cooking something rapidly. Rapidly means, what does rapidly means, students? Rapidly, to cooking something rapidly. Rapidly means, yes, we cook. Yes, rapidly mean in a short time. Okay, so you must cook in a very fast, okay, in a very short time, rapid. Okay, so give reason for the suitability of the characteristic. So material for making the pot, which one is a better choice? Use clay or use copper? Use clay or copper, the material of making the pot?
Copper.
So we choose copper. So you can write copper, or you can write a material with low specific heat capacity. It is also acceptable. Okay. Reason why choose copper, students?
It needs more amounts of energy to rise up the temperature compared to the clay pot.
It needs.
Small amount of energy compared
Okay.
to
So
clay pot.
okay, yeah, it's true, correct. Or you can just write it heat up faster, it is a good heat conductor, or you can also say low specific heat capacity as for the reason here. Boleh tambah satu lagi, low specific heat capacity, or it heat up faster, it is a good heat conductor. Okay. You jangan cakap, so it can cook something rapidly. Okay, it can cook fast. You cannot write the answer which is already stated in the questions. Okay. Okay, then second, material for making the handle of the pot. Students, boys and girls, what material is suitable to make the handle? Is it clay handle or polymer handle? Okay, from our
Polymer
mana
handle.
nak pilih? Polymer or clay?
Polymer.
Polymer.
So we choose polymer. Yes, polymer. Okay, you choose polymer, or you can write a material with large specific heat capacity. So why we choose polymer? Okay, again you can say it heats up slower, or it is a good heat insulator.
Teacher,
Okay, it
can
is
I write reduce heat loss?
reduce heat loss. That is not the purpose. Okay.
Oh, okay.
Because we don't want the handle to get hot quickly, so we choose a material with large specific heat capacity. So you can say it does not get hot quickly, also acceptable. Okay, or same meaning with heat up slower. Okay, slowly, bukan slower, slowly. Sorry, wrong spelling there. Okay, or you can say it is a good heat insulator. Alright. Okay, then how about the mass of the pot? 3.5, we have 2.5 here. So we want to choose a greater mass or a smaller mass.
Smaller
Okay,
mass.
which one? Okay, we choose a smaller mass. Okay, small mass. Why? Why choose a material with a small mass?
The smaller the mass, the greater the increase of temperature.
Okay, this one for the reason you think logic use smaller, so senang nak angkat. Okay, lighter. Okay, easy to carry. Ataupun you boleh tulis juga as what say by Nicholas. Okay, the smaller the mass, what is it? The lower the amount of heat required to raise up the temperature. Okay, but normally when we are talking about mass, so normally we give a reason because it is lighter. Okay, easy for you to carry. Okay, so all together if you count, it will provided 8 marks. Berapa markah dekat sini? Okay. Okay, now let's check on the next question. Okay, we are not finished yet. Question 8 ini dia total together is 12 marks. Okay. Question C. Okay, now we have to calculate. The pots are heated by using an electric hot plate of power 800 watts. So this one you can highlight. Okay, based on the information given on table 8, you have to find the time taken to achieve a temperature rise of 90 degrees Celsius for both clay pot and copper pot. Okay. So how to find the time taken to achieve a temperature rise of 90 degrees Celsius for clay pot and copper pot. Okay, you may count. I give you a few minutes to count what is the time taken for both pot to achieve a temperature rise of 90 degree Celsius. Okay, are you done? Okay, are you done, students? Okay, so let's check the answer together. Okay, so for the clay pot, so what is the equation we apply here? So we are using electrical appliances to supply the heat. So the energy is PT equal MC delta theta. So this is the conversion of energy. Heat supply by the heater equal to the heat absorbed, okay, by the pot. So we are looking for T. So this is the mass of the clay pot, 3.5. The specific heat capacity is 900 and the temperature rise is 90 degree. So this is the power, divide by 800. So by this, it will give you 354.38 seconds. Okay, for the clay pot. This is the time required to achieve the temperature rise of 90 degree Celsius. While for the copper pot, again, this is the conversion of energy, electrical energy supply equal to the heat energy absorbed or gained by the copper pot. So we are looking for the time. This is the mass of the copper pot, 2.5. This is its specific heat capacity and temperature rise, and this is the power. So it will give you 109.69 seconds. So you can see copper pot requires shorter time, okay, to rise up the temperature of 90 degrees Celsius, which means it can use to cook the food rapidly, okay, faster in a shorter time. So the final question, determine the most suitable pot that is safest to handle and can be heated in a shortest period of time. So we choose copper pot. Alright, easy, right? So we choose copper pot. So I hope you're clear how to solve this kind of questions, especially on the calculation, what formula is to be applied. Okay, so we move to the next question. This is SPM 2018. Ada abang kakak tak ambil SPM 2018? Do you have any siblings who sit for the exam on that year? Okay, none. Okay, so what do we have here? This is a diagram. It shows a baby bottle that is filled with 0.05 kilogram of hot water. So this one you have to highlight the information. The hot water in the bottle is then mixed with 0.3 kilogram of cold water to prepare milk for the baby. Temperature of hot water and cold water are shown at the dispenser. Okay, the specific heat capacity of the water is 4,200 joule per kilogram per degree Celsius. Okay, students. So what is the first questions? Okay, welcome Junwei. Okay, the first question, find the final temperature of the mixed water. So we add in hot water together with cold water. So what happened between them? There is a thermal contact, and finally they will reach thermal equilibrium. So what is the final temperature when thermal equilibrium is achieved? Okay, so please try to work on this. So this is the equation we apply. M1C delta theta 1 equal M2C delta theta 2. Okay, the heat loss by the hot water equal to the heat gain by the cold water. Okay. Okay, try to work with your calculator. Find the final temperature of the mixed water. Make sure you know how to deal with this kind of question sebab soalan ini selalu tanya. Okay, what is the final temperature of mixture of two liquids? Okay, are you done? Okay, I'll show you the answer later. You try on them first. I'll give you a few minutes to settle with the questions. Okay. So class, how to solve this problem? Find the final temperature of the water. So this is the substitution from M1 C delta theta 1 equal M2 C delta theta 2. So this is for the hot water 0.05. Okay, this is the specific heat capacity and this is the temperature change. Okay, so students, initially the hot water is at 90 degree. Okay, so when thermal equilibrium achieved, the final temperature will be lower. Okay, so that's why we place here 90 minus T. T is the final temperature. And for the cold water of 0.3 kilogram, this is the specific heat capacity. So what happened to the cold water after thermal equilibrium is achieved? Its final temperature will be higher than 30. So that's why for the temperature change, we write here T minus 30. Okay, so from there, we can find the final temperature of the mixture is 38.57 degree Celsius. Okay, 38.57 degree Celsius. So I want you to pay attention here how to write the temperature change. Okay, hot water, final temperature lower. That's why 90 minus T. For the cold water, the final temperature is higher than 30. So the temperature change is T minus 30. T is the final temperature when thermal equilibrium achieved. Okay, so clear with that? Okay, now we continue with question B. Okay, B1. The milk is given to a baby who drink only half of it. Okay, what will happen to the temperature of the leftover milk in the bottle after a few hours? So what happened to the leftover after a few hours? You have to give one reason for your answer. Okay, can you respond to me what happened to the leftover milk after a few hours? What happened to the temperature after a few hours?
Decrease.
Decreases. Okay, any other answer? So it will be decreases. Very good. Or lower. Okay, it will be decreases. Why? Because heat loss to the surrounding. Okay, this is the reason. So the temperature decreases due to heat loss to surrounding. Okay, now B2 is a KBAT questions. It's a hot questions. Suggest one way to keep the milk warm for a longer time. Give one reason for your answer. So how to make sure the milk keep hot for a longer, keep warm for a longer time. Students, what can we do?
Immerse in hot water.
Immerse in hot water. Okay, any other idea?
Uh, Cover the bottle with insulator such
Cover.
as the
Yes.
cloth tissue or something like that.
Okay, very good. Cover the bottle with heat insulator. Okay, any other method we can apply other than immerse the bottle into hot water or cover it with insulator? Anything else you can think? Okay, Wanja, Eliana,
Uh,
Ante.
Put outside. Put at
Put inside where?
outside. How outside below the sun.
Put below the sun.
Yes, because that is the gradient is not so not so
But
good.
do you think it's logic to put the bottle below the sun?
Okay. Okay.
uh, uh, Actually, nothing wrong with that. But if you do logically, we didn't do that. Okay, we didn't do that action because it will be exposed to a bacteria. Then okay, so then. So you can wrap the bottle with insulator. So the insulator can be cloth, it can be tissue, it can be magazine paper or any type of insulator. Okay, or you can place also in a thermos. Okay, you can keep the bottle into a thermos inside. Put the milk into a thermos. Okay, or you can immerse it in a warm water, as said by Nicholas. So all this method is to reduce heat loss to the surrounding. Okay, whatever the method you do, it is due to the same reason to reduce heat loss to surrounding. Okay. So this is SPM 2018. 2021, I don't know what kind of question will come out. Okay, if it is related to heat. Okay, kita tengok sekarang essay question. Okay, example of essay question. Okay, the first essay question, this is example of essay question in section C. Okay, remember student, for KSSM, essay question for section C, now you don't have any choice because only one question there in section C. Mean it is a mandatory for you to answer. Either you know it or not, no choices. Okay, compulsory to answer. Section C, an essay on modification. So let's check what do we have here. You are given two diagram, 9.1 and 9.2. Show the reading of thermometer when the amount of water is heated for 5 minutes. So all this information you can highlight. Okay, and both immersion heaters have the same specification. Okay, what is meant by same specification? Can you tell? Same specification refers to what?
Specific heat capacity.
The heater. Both immersion heater has the same specification. Mean they supply the same amount of power. Okay, they supply the same amount of power to the water. Okay, so first, what is meant of heat? Students, what is the meaning of heat? Okay, what is heat? What is heat?
Is one type of energy.
One type of energy. Heat is an energy, Chan Wei-She said. Okay, heat is a type of energy. You just write energy, it's enough. Okay, ada energy di sana, satu markah. A form of energy, a type of energy, or just write energy, 1 mark. Okay, and now number 2, using diagram 9.1 and 9.2, compare the reading of both thermometers. So this is 5 marks essay question. You have to make 3 comparison and then later to write 2 relationship. Okay, 3 comparison and 2 relationship. So first compare what? Compare the reading of both thermometer. Second, compare the volume of water. So you have to highlight all this. First, compare the thermometer, number 1. Second, compare the volume, okay, of the water in the polystyrene cup. And then compare the time of heating. Okay, this is the third comparison in the third point, the third mark. And then finally, you have to relate the reading of thermometer with volume of water. Okay, what is the relationship between reading of thermometer and volume? And then finally, what is the relationship between increase in temperature and mass of water? Okay, so first and foremost, how do we compare? How to compare the thermometer? So you have to look clearly where is the level of the mercury in both diagram. Okay, the first diagram, you can see this is the level of the mercury in 9.1. And then below here, this is the level of mercury. Okay, so what can you say about the temperature? Which one higher, which one lower?
9.1 is greater than 9.2.
Okay, so you can say dia ni terbalik, dia tekan volume dulu. Okay, so nanti cikgu susun semula. Okay, first point, reading of thermometer 9.2. Sepatutnya ini lower. Sorry, ada wrong. Cikgu betulkan dulu. Ada wrong answer di sana. Okay, reading of thermometer in 9.2 supposed to be smaller. Okay, 9.2 smaller than 9.1. This should be your first point. Okay, then second, compare the volume. Okay, how about the volume? Okay, look at the volume. Which one higher, which one lower? 9.1.
9.2 is higher than
9.2, yes, 9.2 higher or 9.1 less than 9.2, okay, as in my diagram. Okay, then third comparison, time of heating the water. Ini time of heating. Compare time of heating. So what can you say about the time of heating between both diagram?
It's the same as
It's
5
the
minutes.
same, right? Okay, it is the same, 5 minutes. So time of heating equal. Okay, remember when you are comparing, it does not necessary to be different all the time. Okay, ada yang sama juga. For example, the time. Okay, so first point, reading of thermometer 9.2 is less than 9.1. Okay, and then volume of water in 9.2 greater than 9.1, or you can say 9.1 less than 9.2. And then the time of heating is equal for both diagram. Both is heating for 5 minutes. This is stated in the questions. Okay, and then how we write the relationship. First, relate the reading of thermometer with volume. So you can see that when the volume of water increases, the thermometer reading decreases. Or you can say inversely proportional. Okay, volume of water inversely proportional to thermometer reading. Alright. And then the third relationship, relate, okay, the increase in temperature and the mass of water. So how to say this? So you can see that when the mass of water is lower, mass is refer to the volume. Okay, when the mass of water is lower, the reading in temperature is higher. So we can say mass of water is inversely proportional with reading increase in temperature. Okay, are you clear how to write a comparison, how to write the relationship? Okay, anything else to ask on this question before we move to the next one?
No.
Okay, so are you clear with how to deal with this kind of question?
Absolutely.
Okay, very good. Lee Huang Yi, welcome. Okay. Okay, then we check on the next questions. Okay, the next question, this is application of concept. Okay, sea breeze phenomena, which we discussed yesterday. You are asked to explain how the sea breeze phenomenon occur during the daytime. So 4 marks, 4 points. Remember how to write sea breeze. So first and foremost, you can talk about the specific heat capacity of the sea water or the land.
Understand.
Okay, macam mana nak cakap?
Okay.
So you can begin with land has lower specific heat capacity. Okay, land has lower specific heat capacity, or you can say the other way around. Sea water has a higher specific heat capacity. Okay, sea breeze. Sea breeze occur at daytime. Okay, what is sea breeze?
Sea breeze is occur due to the different specific heat capacity of land and seawater. When the temperature of the land is higher than the sea, then the hot air will rise up and there will appear an partial vacuum space and cause cold the cold air flow to the land space and occur sea breeze.
Okay, very good. Full marks. Okay, full mark for that answer. Congratulations. Okay, so first you can talk. Okay, land has a lower specific heat capacity. Then it will get hot faster. Okay, compared to the sea. So the hot air above the land rise up and produce low pressure region or partial vacuum region. And as the result, the cold air from the sea move towards the land. So this is what we call as a sea breeze, the movement of cold air from the sea towards land. Okay, so 4 marks for 1 mark for each point. Okay,
Sure.
then yes.
Is specific heat capacity cause convection or convection cause this?
Sorry?
Convection is
Convection is the method of how the heat transfer. Okay. Convection means heat is transferred through air. Okay. But this phenomenon is due to the difference in specific heat capacity for both sea and land. Okay?
Okay.
Okay, now we go to the long essay questions. Okay, long essay question. This kind of essay is known as modification. Okay, modification essay. So you are given a diagram. It shows a car radiator system which is not very efficient. So you have to do some modification on the initial model to create a new model which is working more efficiently. So you are required to modify the car radiator system so it can cool the engine effectively. So your modification must be based on the aspects given. The first one is the size. Okay, size of the fan used. Second, number of fin blade. Third, material of the fin blade. And number 4, the specific heat capacity of the cooling liquid used. And the last but not least, the boiling point of the cooling liquid used. So you must follow these given aspects. So how to write our modification? So remember student, for long essay question, you are highly recommended to answer them in the form of table. Okay, so first you can create your table with 2 columns, modification and then reason or explanation. So these are the aspects we are going to look for. Size of the fan. So it should be big or should be small?
Should be big.
Should be big, okay? It should be big. Big fan, okay? Big size of fan. Why the fan must be big? Okay, why the fan must be big?
To suck more cold air.
Okay, very good. So, can suck in more cool air to the radiator. Okay.
What
Or,
is fin blade?
yeah,
Fin blade.
fin blade, this one. You can see this fin blade. Okay, this one, the blade. Okay, this is where the air going through into the radiator. Okay. Sini ada space. If you look at your
The space.
aircon, the spaces. Okay, if you look at your
Okay.
aircon, okay, behind the aircon itu dia ada fin blade like this. Okay, a very small blade. Okay, where the air move in and out from the aircon or from the car radiator system. Okay, second, number of fin blade should be more or should be less?
More.
Should be more. Okay, more number of fin blade or high number of fin blade. So this one can be high or you can say more number of fin blade, many fin blade. Why?
Allow more air to flow in.
Allow more for air to flow in, or you can say larger surface area for more heat to release. Sama juga allow more air to let in. Okay, then second, material of the fin blade. Okay, the fin blade must be made from what kind of material? So normally for the fin blade, it is made of metal. Or to go more specific, it is made from copper. Okay, why made from copper? Okay, do you have any idea why made from metal or why made from copper? So because copper or metal has a low specific heat capacity. Okay, copper with low specific heat capacity, so it will release heat easily. Okay, it can release heat easily from the engine. Okay, number 4, specific heat capacity of the cooling liquid used. Okay, normally we use what kind of liquid as the coolant, students?
Water.
Water. Why we choose water?
Because of high
Yes.
capacity.
Okay, so we choose a coolant liquid of high specific heat capacity. Why? So that
So
it
that it can absorb more heat energy.
Yes, very good. It can absorb more heat. Okay, it heat up slowly. Okay, not easily boil, and it can absorb more heat from the engine. And the last aspect, the last modification on boiling point of the cooling liquid used. This is very easy. So we choose a liquid with high or low boiling point.
Higher.
Okay, definitely we choose a liquid with high boiling point. Yes, insinuate high boiling point. Why? So that,
Prevent the liquid become gases.
yes, so it won't boil easily or it does not evaporate easily. Okay, not boil easily or not convert into gas easily, or you can say not vaporize easily. Okay, so by this, they give you 10 marks. Okay, 5 marks for modification and then 5 marks for the reason. But students, you have to remember, sometimes they only give you 3 aspects here. Kadang-kadang dia tak bagi 5, dia bagi 3 aspek saja. Okay, if they give you 3 aspects only, still you have to write minimum of 5 modification and minimum of 5 reason, which means that there is an aspect you can write 2 points for each. Okay, so remember, if they give you less than 5 aspects, still you have to write minimum of 5 modification and 5 explanation in order to secure you 10 marks. Alright, okay, are you clear with the format? Okay, anything else you want to ask on this before we move to the final question for today? No? Okay, then very good. Okay, we proceed with the last example of essay question. This is example of question in section B. Okay, in section B. Okay, what is the difference between essay in section B and C? You will see the difference in the long essay. Okay, the long essay, the 10 essay mark. And also for essay in section B, there will be one question asking on calculation. Okay, which allocate 5 marks. Essay for section C, no calculation at all. But in section B, we have one part which allocate 5 marks for the calculation. Okay, so this is the diagram you are given with. It shows metal block M with a mass of 500 gram heated in a boiling water of temperature 100 for a long time. Okay, and then it is quickly transferred to 200 gram of water at 30 degrees Celsius in a polystyrene cup. The water is stirred until thermal equilibrium is achieved. So first question, what is meant by thermal equilibrium? Okay, what is thermal equilibrium? Okay,
Two objects reach same temperature.
okay, itu not complete answer. Tak ada markah if you answer like that. Okay, so first and foremost, you can say that, okay, two bodies are said to be in thermal equilibrium when net heat flow between the two bodies is zero and both bodies are at the same temperature. Okay, this one you boleh kemaskan lagi. Okay, ini you boleh, this one you can skip. Okay, so you can start it here. Okay, you can start it with here. The net heat flow between the two bodies in thermal contact. Okay, you add in here. Okay, the net flow of heat between the two bodies in thermal contact is zero. So this is the first point. Two bodies in thermal contact. Okay, the first keyword. And then the net flow of heat is zero. Okay, this is the second keyword. Net heat flow is zero. And then the third keyword, same temperature. So in order to get mark for this, you must mention two bodies in thermal contact, net heat flow is zero, then temperature is the same. Okay, 3 keywords. Never miss them. Okay, then we go to the next question. Tengok soalan yang seterusnya. Okay, the next question, they ask you to explain in terms of thermal equilibrium how a thermometer which is placed into the boiling water reads the temperature 100 degrees Celsius. 4 marks. So this is working principle of thermometer. So students, the thermometer works based on thermal equilibrium. So you must say first heat flow from hot water to the thermometer until thermal equilibrium is reached. Okay, and then what happened? The temperature of water is the same as the temperature shown by thermometer. then no net heat flow. Jawapan ni sebenarnya susunan dia tak begitu cantik. So the first point you can say heat flow from the hot water to the thermometer. Okay. Second, until it reach thermal equilibrium. And then this one supposed to be the third point. No net heat flow. Mean net heat flow is 0. Okay. And then finally only we say the temperature of hot water is the same as temperature shown by the thermometer. Okay. Okay, next question B1. Okay, B1. Find the final temperature of the water in the polystyrene cup. Okay, this is similar to the previous question before where the heat absorbed by the water equal to the heat loss by the cube M. Okay, so we can write M1 C delta theta 1 equal M2 C delta theta 2. So you can write the substitution. So the heat, the water absorb heat, so the final temperature is higher, okay, compared to the initial temperature. While the cube M, the metal lost heat. So that's why the final temperature is lower than the initial temperature of 100. So by this, we can find the final temperature of the mixture, which is 52.58 degree Celsius. Okay, you can count and check either you get the same answer with me. Okay, and what is the assumption we made in our calculation? Okay, can you tell me what is the assumption we made here?
Conversation or conservation of heat energy.
Conservation of heat energy. So we say no heat loss to the surrounding. Remember, whenever we do a calculation, we always assume that there is no heat loss to the surrounding. So heat absorbed by water equal to the heat loss by cube air, 1 to M conversions. Okay, no heat loss. So efficient conversions of heat. Okay, now the last question for today, long essay. Okay, for this kind of essay in section B, they normally will give you a table. Okay, you have 4 choices of objects or 4 choices of thermos plus here W, X, Y, and Z, and they give you 4 characteristics for each for you to determine which thermos is the most suitable to use. Okay, to keep the temperature of hot drink inside the thermos. So they give you the stopper, space P, and the double wall tube made of glass or copper, either coated with shiny paint or black paint. Stopper, you have 2 choices. Is it hollow or is it solid plastic? The better choice. Space P, must it be vacuum or must it fill with air? And this is additional information, specific capacity of glass and copper for each. So again, in order to write the answer for this, normally we prepare a table, characteristic and reason. So the first characteristic, which stopper? Solid or plastic stopper? Which one?
Solid.
We choose plastic stopper. Okay. Plastic stopper mean it is a hollow stopper. Okay.
What
Solid
means
means a
hollow?
compact. So we choose a hollow plastic stopper. Why? Hollow plastic
Insulator.
stopper. So it acts as an insulator. Okay, can trap air. It's a bad heat conductor or it is an insulator. You can write there. Okay. Second characteristic. Glass P. It should be vacuum. Space X should be vacuum or should be filled with air. So it should be vacuum. Okay. To prevent heat loss through convection.
Why is
Okay. Vacuum, so mean no air. So no air to transfer the heat from the thermos outside to the bottle. Okay, prevent to prevent heat loss. We can prevent heat loss by convection. Okay, this one. So it should be vacuum. All right. Okay, and then next, the glass wall, the double glass wall must be made of glass or made of copper. So this one very obvious. So we choose glass. Why? Because glass is a material with high specific heat capacity. Or you can say it is a heat insulator or a poor heat conductor, or it heat up slowly. Okay, so there are more than one reason you can write here. Okay, and then second, the double wall should be coated with shiny paint or black paint.
Shiny paint.
So shiny, why shiny? Okay.
Absorb least energy.
So it is a good heat reflector, absorb least energy, reflect heat from the wall of the thermos. So which thermos is a better choice? W, X, Y, O, Z. W, X, Y, O, Z. I think this one is space P, not space X. Okay, so which one is a better choice, student? Thermos W, X, Y, or Z? So we choose W. Okay, we choose thermos W. Why? It is a hollow, it has a hollow plastic stopper. It has a vacuum space P. The double wall made of glass and coated with shiny paint. Okay, so by this, you have all 10 marks. So 4 marks for the characteristic, and then 4 marks for the reason. Mark number 9 when you choose correctly, choose W. And mark number 10 is the combination of characteristic of W. Okay, so you can see what is the difference between the essay in section B and essay in section C. Okay, any further question before we end this session?
Teacher, is it possible that the final answer is not in the question given?
No, there must be one material which fulfill most of the characteristic. Okay, which fulfill the most of the, so you choose the material which fulfill most of the characteristic. Okay, sometimes in some question it doesn't meet all, so you choose the maximum. Okay, which material fulfill the maximum characteristic, so we choose that object, that material. Okay. Okay, so anything else? So I guess you are clear how to deal with specific heat capacity, and please do more exercises for better understanding. So I guess that's all for this week. You can always refer back to this video if there's any part you're not clear with. So then you can ask me anytime, okay, at the Telegram group. You can PM me personally. So I hope you can put more effort at studying at home, and at the same time, please do take care of yourself. Tolong jaga diri, jaga kesihatan. Okay, so if there's nothing else, you can leave this meeting now and then move to the next lesson. Again, students, thank you very much for your effort. I really appreciate them. Okay, so see you again next week. Bye-bye for now. Okay, and have a great day ahead. All right.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.